Hi, I'm Mike. I'm with Nuts About Nets. We develop wireless diagnostic tools, and today I want to talk about RF spectrum analyzers. So an RF spectrum analyzer is an amazing device because the data it provides is very powerful and very useful. It's used for designing and troubleshooting wireless systems. Just as humans use sound waves to communicate from one person to another, wireless devices use radio waves to communicate from one point to another. In order for a wave to move through a medium, in this case the medium would be air, energy is required. That's what the RF spectrum analyzer measures. The good news is that it's easy to use and the data is easy to interpret. An RF spectrum analyzer is the tool of choice when working with wireless systems. Why is that? It's the only instrument capable of measuring RF signals across the spectrum. Furthermore, the information presented by an RF spectrum trace is most useful when designing or troubleshooting wireless systems. Let's see an RF spectrum analyzer in action. An RF spectrum analyzer is similar to the radio we're familiar with in our cars or at home. If we tune to a particular station, also referred to as a channel or a frequency, our radio detects the RF signal currently being broadcast at the frequency we've tuned to. An RF spectrum analyzer sweeps across all the frequencies within a particular range or frequency band, that is to say, a spectrum of frequencies, and measures the strength of the transmitted RF signal at each frequency. The RF spectrum analyzer repeats its sweep over and over again. The result of each sweep is displayed and is called an RF spectrum trace. Each peak in a spectrum trace represents a transmitted signal. Here, you can see the spectrum trace of the FM band from 88 to 108 MHz. Each peak represents a different broadcast station transmitting an RF signal at a particular frequency. Within the FM band, each broadcast station requires a license from the FCC to broadcast at a particular frequency. There are certain bands, for example the 2.4 and 5 GHz ISM bands, that do not require a license for broadcasting or transmitting RF signals. RF spectrum analyzers were first introduced in the early 1960s. Today, they come in a variety of sizes, from large bench-top models that weigh more than 30 pounds, to portable luggable devices that weigh about 10 pounds, to handheld models and even USB dongles, and costs range anywhere from tens of thousands of dollars down to just a few hundred. Since cost is no longer a barrier to owning an RF spectrum analyzer, it's a valuable addition to anyone's toolbox. Anyone who considers themselves technically inclined and who needs to troubleshoot RF problems or check for RF interference that may be degrading their wireless system or configure a wireless system should consider this device.